Now, if you remember the mean-value theorem, you might remember that it's a generalization of Rolle's theorem that we just looked at a few minutes ago. Rolle's theorem said under the right conditions for the function being continuous on a closed and bounded interval, this would be our function f, somewhere between a and b is a point x0 where the tangent line is going to be horizontal. In other words, f prime at x0 is equal to 0. Well, notice the line connecting a to b, since they're on the x-axis, also is a horizontal line, has a slope of 0. So these are two parallel lines. Well, what the mean-value theorem does, for example, if I were to take this function and tilt it upward, now a and b are no longer both on the x-axis. But if I think about the line that connects f of a to f of b, there's going to be some point on the graph that has that as its slope, or the value of the derivative. In this case, it'd be right about there. In this case, f prime, evaluated at x0, would be the same number that is the slope of the line connecting this point with that point. Okay, let's state and prove the mean-value theorem, theorem 4.8. If f is continuous on the closed bounded interval ab and differentiable on the open interval ab, then there is some point in the interval, open interval ab, such that f prime of c is equal to this. Now notice what this is. This is the slope of the line connecting a comma f of a to or with b comma f of b. We showed that in the picture just a minute or two ago. This is the slope of the line that connects a f of a with b f of b. All right, well, let's get the equation of that line. Let's hit proof. First off, we're just going to note or notice that the line connecting those points that I just listed a f of a to b f of b is, okay, we're going to use the point slope formula. We could think of this as being x1, y1, and x2, y2, if you remember the formula from pre-calculus. Y minus y1, which is f of a, equals m, the slope, which is this, f of b minus f of a over b minus a, times x minus x1. And our x1 is a. So that's just the point slope formula for the line that passes through both of these points. I can rewrite that as, let me see, I think I'm going to write it, instead of y, I'm going to use f of x, or in this case actually L of x, is equal to the slope f of b minus f of a over b minus a times x minus a plus f of a. So all I did is a little bit of rearranging to get the equation of the line to look like that. All right, well, obviously, L of x is continuous and differentiable because f is, on all of r, it's a straight line. Any straight line in the form of y equals mx plus b, or in this form, is continuous and differentiable on the entire real line, and it has a derivative. L prime of x would be what? Nothing but the slope of that line. This is it. F of b minus f of a all over b minus a. Okay, let's, I'm going to squeeze in a little bit right here. Let g be the function f minus the function L. F minus this function. Okay, G is it's continuous on the closed interval. It's differentiable on the open interval. Continuous on closed AV. Differentiable on open interval A to B. And we get the following. G of A is equal to, obviously, f of A minus L of A, just by the definition of L, is equal to 0. That's pretty easy simply to plug in. Let's see, where's f? I've got f of a minus L of a. Well, when you plug in L of a, you get a minus a, which knocks all of that out. So we end up with f of a minus f of a, which is equal to 0. That's easy. G of b is equal to f of b minus f of a is also equal to 0. It just takes a few lines. I'm going to put problem for the student to verify that. Just plug b into the function g. We'll actually plug b into the function L, and you will find out that it's 0. Okay, running out of room here, 2 more sentences, so I'm going to start off over here. Thus, by theorem 4.7, Rolle's theorem, there exists a C in the open interval A to B where such that G prime of C is equal to 0. And I think I can get one more sentence and we're done. I'm not going to write out therefore. The 3 dots here means therefore. Let's see. Since 0 is equal to G prime of C, but G prime of C is, let's see, G prime should be F prime of C minus L prime of C. And that is equal to F prime of C minus that previous slope that we computed, F of B minus F of A all over B minus A. And that's obviously equal to 0. 0 is equal to all of that. So to finish it off, I'm just going to say that implies that F prime of C is equal to F of B minus F of A all over B minus A. And that's what we tried to prove. We found the C such that f prime of c is equal to exactly that.